Hey guys, so today we're gonna solve the graph problem. Basically, this problem are asking us to return the total disconnected and connected components. Well, let me explain. So, this is the given problem, right? The key is on here. What is the profits means at here, at this context, right? The profits is a group of directly or indirectly connected city that have no other city outside of the group. And what is the input? They are giving us the matrix, right, that are visualize the connected cities, and the expected output is the total number of provinces, right? Let's take a look at the example 1. As we can see it here, city 1 is connected to city 2, right? So they are considered as one province. Meanwhile, for city 3, they are not connected to any other city. They are also considered as one province. So for the example 1, the total number of province is 2, right? Let's move to example 2, right? As we can see it here, there are 3 nodes at here, and they are not connected to each other, so each of them are considered as one province. So the expected output for example 2 is 3 provinces, right? Then let's move to example 3. As we can see it here, city 1 and city 2 are connected to each other, right? So they are considered as one province. And at here, city 3 are connected to city 5, right? They also considered as one province. City 4 are not connected to any other city. This also considered as one province. And city 6 are not connected to any other city, so they also considered as one province. Total of the province at here is 4, right? Basically, this problem just simply asking us to return how many connected and disconnected components. While how can we solve it? Usually to solve this problem, first we need to create the adjacency list to visualize the connected cities, which is already done, right? On the input itself is already visualize the connected city. So what is the step 2? We need to create the visited node to mark its cities that we visit, right? And for every disconnected city, we do DFS. The return is total number of times we do DFS is equal to number of province. So first, let me visualize this into a table, okay? Okay. Adjacency list, insert, okay, this one is 1, 2, 3, 4, 5, 6. City 1 is 2, city 1 connected to city 2 are not connected to city 3, false, false, false. 2, 2, false, false, false. City 3 are not connected to city 2, right? 4 are not, yes, connected. False, 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 2, false, false. This one is false, false, 2, false, true, false. Then this one is not connected to any other city, right? Okay, the adjacency list is done. Let me click the visited node. This will be like this. 3, 4, 5. This one is represent city 1. Index 1 is represent city 2. Index 2 represent city 3, and so on. Let me type it first. city 5, city 6, right? Okay, now we already do that, right? Then we're gonna visit each of the city, right? We start from index 0, which is the city 1, right? Have we visited the city 1? No, right? True. So we call DFS 0, right? Then we mark them as visited. Visited not. Zero is true. Mark city 1 as visited here. Then we explore the neighbor, right? Do they have any neighbor? Yes, which is city 2, right? And city 2 is represented by index 1. So we call DFS 1, right? Then inside of the DFS 1, we mark the city 2 as visited, right? Mark city 2 as visited here. Then we explore the neighbors, right? They have the city 2 have the neighbor which is city 1, right? Are they have been visited? Yes. So skip, because city 1 not 0 is already visited, right? So we move to index 1. Have they visited? Have we visited the city 2? Yes, right? So it will be false. Already visited, skip, right? Move to index 2. Have we visited the index 2, which is, that means city 3, right? So we haven't visited, right? So we call DFS 2, right? Then mark them as, let me just copy this. Mark them as visited, right? Mark city 3 as visited here. True. Explore the neighbor. Do they have any neighbor? Yes, right? City 3 have the neighbor of 5, right? City 5 are represented by index 4. So we call the DFS 4, right? Then we also mark them as visited. This. Then okay, explore the neighbor. Do city 5 have any neighbor? Yes, city 3, right? But city 3 is already visited, so we skip it, right? Skip, because city 3, which is not 2, already visited, right? Then we move, right? Do they have any neighbor? No anymore, right? So we move to index 3. Have they visited? Index 3. Have we visited index 3, which is city 4, right? No, we haven't visited. So true, then we call the DFS 3, right? Then we mark them as visited, right? Here, explore the neighbor. Is city 4 have any neighbor? No, right? So skip, no neighbor at all. Then we move to index 4, which is city 5, right? Let me type it. False, because they already visited, right? Yep. Then we skip. We move to index 5, which is city 6, right? Have we visited? No. So I'm just gonna copy this. Yes, we haven't visited the index 5 visit city 6, right? So we visit them, then we mark them as visited, no neighbor at all, right? Then exit the looping, return total number of times we do DFS. How many times we do the DFS? 1, 2, 3, 4, right? So we have 4 provinces from the given input, right? Let me mark this. Okay, can we turn them into a code? Yeah, sure, let me turn them. Const number of province, the input is connected, right? First we need the n, that is how many length, this is 3%, how many cities. Okay, then after that we need the, because they already give us the adjacency list, right, on the input, so basically we don't need to click the adjacency list anymore. So we're gonna move to step 2, right, here, which is we click the visited node, right? So let visited node from new array, and the length is total of the city, right? We fill with false because we haven't visited, right? Then we also need the number of province. We start with 0, let e is 0, e is smaller than the n, visit each cities, then we do e++. If the city haven't visited yet, we're gonna do the DFS, right? DFS I, then we also increase the number of province. The result, this will be return number of province. Then let's click the DFS. Current city, right? Mark the visited node of the current city as true. Mark it as visited. Then we explore the neighbors for 0, let e is 0, then e is smaller than n, e++. If is connected, current city have any neighbor which is represented by 1, right, and haven't visited yet, and the neighbor haven't visited yet, check if they are neighbor or connected and haven't visited yet. Then what do? We do the DFS on the neighbor. Okay, let's do the dry run, right? Okay, let's get this example because it's quite simple for us to do a quick dry run. Okay, this is the adjacency list to visualize the connected city, right? First, we start with index 0. Have we visited the index 0? No, right? So we call the DFS 0. Then we also increase the number of province, right? This is one province. Then after that, inside of the DFS, we mark the index 0 as visited, right? True. And here the visited node will be true, false, false. Then we explore the neighbors, right? Is city 1 have any neighbors? Yes, which is city 2, right? Only have one neighbors, which is city 2, represented by index 1, and haven't visited. So we call DFS 1, right? DFS 1, we visited the city 2 and mark it as visited. So the visited node will be 1, 1, 0. Okay, do they have any neighbor? No, right? So we move to index 1. Digit index 1 haven't visited yet? False. So skip, because already visited. So we move to index 2, right? Which is represent the city 3. Have we visited them? No, right? So we call them DFS 2 and increase the number of province. This is 2, DFS 2. We're gonna mark them as visited DFS 2. Okay, explore the neighbor. No neighbors. Skip. Okay, then we exit the looping. Return number of province, which is 2. Okay, so the codes are working, right? And I think like this all for the dry run. Let's do the time and space complexity analysis, right? This one, because we are visiting each of the nodes, right? So it will be O V time. Each time we do the DFS, it's also O V time. At here, this one is O V time. So because this one is O V time and this one is also O V time, the time complexity will be O V quadrant 2 time. And how about the space? The space, we only use the visited node, right? Which is O V space. So the space complexity is O V space. I think like this all. Then let's see if the codes are working, right? Let's just simply copy this into here. This is return. Oh, I will just rewrite it anyway. So first we need the total of the city, right? Which is connected dot length. This one is represent the total of cities. Then we need the visited node, right? This is new array from n, then fill with false to mark its visited city. Okay, after that, what do we need? We need the number of province itself, which is we start with 0, then we start visited each of the city, right? Which is start from 0, e is smaller than and we just e plus plus, right? Then if they haven't visited yet, we increase the number of province, then do the DFS, right? What we return is number of province. Here is the DFS, current city. We mark the current city as visited, right? Mark as visited. Then explore the neighbors, right? So for let e is 0, e is smaller than n, e plus plus. If they are connected to each other, which is represented by this current city and haven't visited yet, we do the DFS E. Okay, let's do the time space complexity analysis. For the space, we only needed extra space to the visited node, right? So it will be or vertex space. Vertex is same with nodes in graph. Meanwhile, for the DFS, because we are exploring all the neighbors through the n times, right? So it will also O v time. This one is also same O v time, which we repeat as O vertex time, and the DFS is O v time, right? So the time complexity will be, this one is option 1, DFS O v quadrant 2 time and O v space. Let's see if they are working. Yay! Let's do the submit. Okay, I think that's all from me. See you next time.